So welcome to another segment, understanding numbers. So I want to give you an example so that you're able to see how you can, deal with some of your numbers that you have. So they have given you numbers like 2 square root of 3, 1 over 1000, negative 99, 2, 1 over 2, which is a mixed fraction, negative 1 over 4. They have given you pi 0.30 and 205. So these are the numbers that we have been given. Then it says from the list given above, select A. They want you to select solution. So they want you to select the natural numbers. So which ones among those are natural numbers? Remember what we said? Natural numbers are simply counting numbers. So when I look at that, the natural numbers that I have, yes, you're right, it's a 2, and I do have also a 2005. So these are the two natural numbers that are there that I can get from that list. Remember, they're counting numbers like we said. Then the integers, which ones are integers? Which one can we go for? Which are integers? Well, of course, integers, remember, represented by a symbol that looks like a Z there. The integers, if I was to list them there, include things like negative 99, that is an integer. That is also, we can include a 0 there, it is an integer. We can also include a 2, is also an integer. We can also include a 2005. So these are examples of integers that we do have. Now remember, why are we calling them as being integers? Remember, I told you they can either be a positive or negative whole numbers with 0 included. Yeah, so that is what we mean. So you need to remember that. All right, so for C, it says the rational numbers. Remember, rational numbers, we did say rational numbers are those numbers that can be expressed in the form A over B. In other words, you can express them as fraction, but the denominator there should not be equal to 0. So therefore, when I talk about rational numbers, the symbol that I told you looks like a symbol that looks like a Q. Numbers would include negative 99 is actually a rational number. Negative 1 over 4 is a rational number. 0 is a rational number. 1 over 1000 is a rational number. 0.3 is a rational number. 2, 1 over 2 is a rational number. 2 itself is a rational number, and 2005 is also a rational number. Well, someone might argue, but how come that one there? Remember, 0, you can write that 0 divided by whatsoever number that you want, it will still give you a 0. So that is why we are saying it is a rational number. So that is what you need to remember. Let's look at the D part. The D part says the irrational numbers. So now when I look at irrational numbers, so from those numbers that they have given us, which ones are irrational? Are irrational numbers. Remember, we said irrational numbers, those numbers that cannot be expressed as fraction, and in most cases they do not have a recurring decimal. In other words, it is non-terminating or non-repeating. That's what we mean. The very good example there is, remember, like I said, the root of something that is a number that is not a perfect square. That is pi, a common one. I think those are the main ones that we do have. Now, the reason why we choose this is because these are decimals that go on forever with no repeating pattern. So they do not show any repeating patterns. If you find the square root of 3, if you have your calculator, if you go to the square root of 3, you are going to find that the square root of 3, there's no repeating pattern that is actually there. So this is simply an irrational number. Pi, again, like I demonstrated, if you look at it, there's no repeating pattern after the decimal point. So therefore, we consider that one as being a rational number. Remember, 1 divided by 3, the 3 keeps on repeating itself. So this is recurring. So this is not an irrational number. It is a rational number, 1 over 3. So that is what you need to remember. Then the last but not the least there, for question number 1, says the real numbers. So what are the real numbers? Remember the symbol that we use that looks like R, that's for real numbers. All these numbers that they have given them put together, they'll make up what we call as being real numbers. So if you want, just get all those numbers. 2 square root of 3, 1 over 1000, negative 99, 2, 1 over 2, negative 1 over 4, your pi, your 0.3, your 0, your 2, your 2005. All these numbers make up what we call as being real numbers. I hope you are getting the sense, and this will help you when it comes to further topics like sets and any other that you are going to encounter. You meet these numbers, so you need to know numbers, understand the numbers. Okay, question number 2 there says write a list of all prime numbers between 20 and 35. Did you understand what we said prime numbers are? Well, when we talk about prime numbers, we did say it is a number that has got only 2 factors, itself or 1. So it can just be itself or 1. Those are what we simply called as being, prime numbers. So what are the prime numbers between? Remember, it says between 20 and 35. When we talk about between 20 and 35, is 20? No, because a lot of numbers. 21? No, 3 and 7 can also go into 21 itself, therefore 23. Yeah, 23, only 23 and 1, and it's 23 and 1 can go into this one. That's all. Another one that we can talk about is 29. Yeah, only 1 and itself can go there. 28, 27, no. 28, no. 29, yes. 30, no. 31, yes. It's actually a prime number. Any other numbers? No. 32, no. 33, no. 34, no. 35, no. So these are the only prime numbers between 20 and 35. Thank you so much. I hope you enjoyed the video. Please, if you enjoyed, you can subscribe so that as I produce more videos, either for physics, chemistry, biology, or mathematics itself, you can benefit. Thank you so much for watching.